In this video, we're going to look at an example where we need to reverse the order of integration in order to be able to do the integral. So let's look at the integral from 0 to 1, integral of root y to 1 of y e to the x squared over x cubed dx dy. Notice that this integrand, if I'm going to try to integrate this with respect to x first, this is not going to be easy, right? I've got an x squared up here in our exponent. I've got an x cubed in the denominator. This is just a mess, okay? So instead of trying to integrate this with respect to x first, let's try to integrate it with respect to y first, because that's easy. All I have is a y, and I know an antiderivative for that pretty quickly. Okay, so let's look at our region that we're integrating over. The x's go from root y to 1. Well, root y equals x is the same thing as x equals, or y equals x squared, which is just this parabola. And then y goes from 0 to 1. Well, if our x's are going from root y to 1, here's x equal to 1, and then their x's go from 0 to 1, we're interested in this shaded region. Well, we can rewrite it now in terms of x first and y first and then x. This is y equals x squared, and this is y equals 0. So the y goes between 0 and x squared, and then my x's go from 0 to 1. So reversing the order of integration here, we get integral from 0 to 1, integral from 0 to x squared of our integrand dy dx. Antiderivative for y is just y squared over 2. When we plug in x squared now, notice that we'll have x to the 4th over x cubed, and we just get an x e to the x squared dx. Now, technically speaking, I really should be doing an improper integral here because I've got a 0 in my denominator when I start here, right? And my integrand is not defined at 0 in this case. So I did not do this, write it out technically, but I really should be handling this as an improper limit of integration, in particular this 0 here for my x, because of that particular issue of plugging 0 in. But notice that issue will go away even when we had that if we did a limit, because this now no longer has an x in the denominator. So anyway, this now can be accomplished with u substitution, and then we can just plug in our endpoints and get that the final answer is 1/2 times the quantity e minus 1.